What is up, guys? Thanks for joining. Now, if you're watching this live stream back after the event, then this is going to be a series of live streams where I try to repair 7 Camco Vortex PA amplifiers. These are pretty beastie things and they are a bespoke circuit design. They seem pretty nice from what I've seen so far. I have never seen this circuit before in my life, never repaired or worked on one of these, and I am less experienced in running or working on mains PA amplifiers compared to car amplifiers. But an amplifier is an amplifier at the end of the day. The only thing that's different really is the power supply, mains SMP versus 12 volt SMP. So we have a lot of knowledge there ready to be applied to the PA amplifiers, and just kind of diving into that a bit more because that's where there's some good money, I think, and quite a lot of blown PA amplifiers around the country, so it'd be good to be able to easily fix those and gain some experience on some of the more commonly used models. So on the bench right here with me today we have the Camco Vortex 4. Starting off with the smaller one, I have a couple of Vortex 4s and then about 4 or 5 Vortex 6s, which are 6,000 watts RMS into 4 ohm bridge or 1 ohm parallel mono. So that's 3,000 watts RMS per channel into 2 ohms. So they are pretty beefy amplifiers for a 2U size. The faults with these amplifiers range from one channel not working with a red light to no power at all, switch my power supply fault, blowing fuses. So we're going to have a whole bunch of different issues here that we can look into and try and resolve. I've started off nice and easy with this Vortex 4. This one supposedly, actually this one on the bench, I've got another one on the floor. These two Vortex 4s supposedly have their power up, but they have an issue with one of the channels. It's either not playing or it's in protect for whatever reason. So I wanted to the one that I look at first be the smaller Vortex 4, just because it's a little bit safer voltages, and one that where the SMP is intact, just so that I can use the oscilloscope and probe the behavior of the SMP, so that I know what to look out for when I'm repairing one of the damaged SMP models with the Vortex 6. So with that said, I hope you enjoy this live stream and this series. It is probably going to be a fair few episodes because I imagine that at least one of these, probably multiple of these, if not all of these, are going to pose quite a challenge. So I thought that I would share my educational journey with learning these amps and repairing them with you guys. So with that said, let's turn our attention to the live stream now. How's it going, guys? What's up with you, Jason? Drew, I don't know how to say that. GT50, Jason, how's it going, buddy? Can't afford gel audio. Jay Holly, what's going on, my guy? Been a while. Lock Dots, don't recognize your user. That's cool. Thanks for jumping on the stream. Adrian with a $20 right at the start of the stream. What's going on? You know, I'm gonna just kind of set the scene a little bit here. We're gonna go for a little bit of a chill vibe this evening, guys. A little bit of background tunes. I hope you don't mind. Nothing too crazy. Just a little bit of background tunes. It was a good vibe. Actually, did this. Had some little background music on when I did a live stream a few weeks ago with Simon 2. It's kind of a nice vibe. It's just kind of chill in it. So yes, ma'am. Thank you very much, Adrian, for the 20. This live stream was sponsored by your live stream crew. Yes, absolutely. I just released a video on the Taramps Big Boss 8, going through that circuit, and I just did a funny little segment where I was like, oh, this video is sponsored by, and then no one, because no one would ever sponsor this channel really. It's not got much going for it, but here we are anyway. Thank you very much, Adrian, for the sponsorship, I guess. What's up, Timbo? What's up? Yo, yo, yo. So, let's get started then on these Camcos. So, the one I have on the bench here, like I said, is a Vortex 4. This is a little smaller than the Vortex 6. Can't remember the power ratings off the top of my head. This one here was supposed to have, the fault of this one was supposed to be, if we look at the sticker on the side here, supposed to be channel A, clip light remains on, clip LED remains on. However, that's not actually the case. I tried powering this up and it actually has a issue with the power supply. There's a blown fuse and I didn't want to just replace the fuse without checking how these power supplies behave before doing that. So I've grabbed another one that's supposedly supposed to be this similar sort of issue here, because like I said, I do want one that does have a working power supply before going too crazy. What's up, Timbo? Alright, now with these amplifiers, the case that you take off is actually on the underside. The board is upside down compared to how you would normally think amplifiers are laid out. So this essentially is the top from a PCB perspective. So let's grab the screwdriver and start taking this thing apart, shall we? Camco, that's a really good quality amp. Yes, I got the impression that these were pretty good actually, Red King. I had actually never heard of this brand prior to getting these amplifiers in for repair, so I'm not a PA amp kind of guy, I'm a car audio repair guy for the most part, so this is a nice introduction to something high quality, I guess. But yeah, they give off all the right vibes of being pretty stout. So let's get this thing apart, see what we're cracking. I think, is this another Vortex 4? Blah, blah, blah. This is covering up the logo. Nah, this is a Vortex 6, okay. I was hoping to start off with a Vortex 4 because they're a little bit smaller, so rail voltages are less scary, but no, I guess we're diving in the deep end with a Vortex 6. David says, just watched the Tyrant Smart 8 video, good job. Did you get a new thermal cam setup? No, it's the same one I've been using for years, buddy. Maybe it looks a bit different on the video there. It's just a really cheap thermal camera from Amazon. Well, I say really cheap. No thermal cameras are really cheap. It was still like £250, but compared to some of the more expensive thermal cams, it wasn't too bad. I had some older DL3000, used them for PA subwoofer, tight bass, good sound, very robust, and heavy as hell. So if it's heavy as hell, it's probably a linear power supply with a big ass transformer sitting in there. These ones, they've switched to a switch mode power supply. Guys, what's interesting though, is that the switch mode power supply in these things is actually using an SG3525, which is the same PWM generation IC that you'll find in many car amplifiers. So it's really cool to see how, you know, these parts kind of are used in many different amplifier applications, given how many options there are in the, you know, out there for you know, PWM ICs and ways to create an SMP. It's just interesting to me that we find the same chips being used over and over again in many different brands. Dual transformers, so say similar to my iNova Pros probably. Yeah, very heavy. Sorry about the slightly yellow tint on the camera, by the way. The color temperature on my DSLR is a bit too high, but for me to change it requires moving the camera and then it will disconnect, and I've already just got it connected again, so you have to deal with a nice warm atmosphere for this evening, if that's alright. If you don't mind. Hello Godfrey, good to see you, buddy. Not that late, I've only just started really. It looks sharper for some reason. It's probably because I was filming it with the DJI Osmo. So yeah, it probably just looked sharper just because the camera I was using was better to film it with. Yalon, long time! Yeah, it's been a little while, buddy. Good to see you. So, just out of interest, who here in the live chat repairs PA amplifiers, mains powered amplifiers? I know some people do, but they might not have started, they may not have joined yet, but yeah, just curious if anyone that's watching at the moment does repairs on PA amps. Okay, so that's the screws for the 6. So, does the Vortex 6 look much different? No. In fact, my guess was correct. It's the same PCB as the Vortex 4. Come on. How do you want to come up? There we go. So this is the Vortex 6. So let's go through the board a little bit here, shall we? Over here we have what I suspect are the bulk capacitors. So these are going to store the rectified mains coming in. These are only 200 volt caps, but we do, by the looks of it, these might be in series here. So 400 volts per sort of pair, if you like. So these are, yeah, these probably are bulk capacitors. Now down here, which you won't be able to see because of the camera, but right down here there's an SG3525 PWM generator IC, which is going to be generating pulses for the SMP. And the SMP MOSFETs or IGBTs, probably IGBTs, are driven by a pair of IR2110s right here. And over here, these are going to be the IGBTs, or thyristors. They're actually marked THY on the board, which is interesting. We've got some diodes on the heatsink over this side, probably rectifiers. Transformer's quite small, isn't it, for how much power this is? Wow, that is actually a tiny transformer. But it's going to be operating at a high frequency, so that's, you know, understandable. But yeah, that is a really, really small transformer. I mean, if you drop this in a car amplifier and told people, hey, this car amplifier is 6,000 watts RMS, they'd be like, eh? I actually think, I don't understand, why do car amplifiers limit the switch mode power supply transformers to like 20 to 30 kilohertz? Why aren't we seeing switch mode power supplies in car amps that are like, you know, excess of 100 kilohertz? It would mean that you could use much smaller transformers. Maybe it's to do with not interfering with Bluetooth signals or DAB radio signals, perhaps. Very strange and annoying. How's it going, Matthew? Timothy, I'd love to send you my JP. Yeah, the shipping would just cost more than the app's probably worth, unfortunately. Yalan says, I repair everything from medical surgery instruments, digital welders, automotive ECUs, clusters. Wow, good job, buddy. That's freaking awesome. That's a load of small caps together in one area. Yeah, so these are going to be the rail caps, I suspect. Not sure, but I suspect these are probably the rail caps. And yeah, there's like a whole group of them here, and they're all kind of different sizes. Look, we've got some small ones, some big ones. It's really interesting how they've laid it out that way, but fair enough. Camco, no worries. You do you, I guess. So just a quick visual inspection then. This one, like I say, it says on the front, channel B, red light. So we can assume that the power supply, switch mode power supply, is fine and operational. Now the fuse that was blown in the Vortex 4 that I had on the bench just when we started, that I didn't want to look at just yet, was this fuse right here. And it's a 200 milliamp fuse. With about a 7 ohm resistance. This one here is fine. So that's cool. This one should come alive. Just checked a couple other fuses on here as well. That's good. Cool. There's one down here as well. Yep, that's alright as well. So I suspect this one will actually come on at least, and we can see what's up with it. Now, I haven't been able to find any service manuals for these or any schematics. So basically we're going to have to kind of learn this, unless someone can find some schematics. I've had a good look online and haven't come across anything, but we're going to kind of have to reverse engineer this a little bit to figure out how it's working and what to do with certain faults. But we do have the user manual online. We have found the user manual, and that tells us what some of the flash codes mean. This amplifier is controlled by an MCU, so it has a microcontroller that's programmed with firmware, and the LEDs will flash different flash codes depending on what the fault is with the amplifier. And one of the really cool things about these amplifiers and how they have been designed is that the microcontroller can actually detect where a fault is in the output circuit. So let's say, for example, the amplifier has DC offset at the speaker terminals. Usually you'd have to go looking for that reason yourself. However, this amplifier is able to tell you whether the DC offset is as a result of a fault with the preamp circuit, the drive circuit, or the outputs themselves. and it will do a different flash sequence depending on which one of those it is. If it doesn't know which one of those it is, then it will do a separate flash sequence for, I don't know, or if there's an output fault that's not DC offset related, it does again another different flash sequence. So it really does tell you what's wrong here. So given that this one apparently comes on, but just one of the channels has a red light, I think we should turn it on and see what the LEDs are saying on the front. So a little bit scary because this is very, very high voltages inside, but it's fine. We're going to turn it on and see what the LEDs are saying. The transformer has air gap in code, like in some SMP power supply. I imagine it will have to with the voltages that it's creating. Okay, so what power connector do these use? So these have, I don't know what the name of it is. Neuralink, is it? Whatever this is. Yeah. Oh, Nutric. It's like Speakon, but different for power. Nutric connector. You can tell how many mains amps I do. Not very many. PowerCon. So safety glasses at the ready, yes, absolutely. Just grab those off the desk. Safety glasses at the ready. And we're going to power it up and just see what the flash sequence is. So I hope that this is currently in the off position, and we're going to flick the switch on the plug here. If the stream goes dead, you know that it's tripped my breaker, okay? Okay, we have operation. It has come alive. It was already on. And yeah, the clip LED is actually just solid red. Interesting. That is not actually one of the fault modes that's listed in the user manual. And the clip LED actually stays on. We have single flashes of the power light. So I've just turned the amplifier, what I assumed was off. Yeah, okay, so that's off. So the switch in the down position is off. So if I go ahead and flick the switch on, we have green LED on one of these channels, and green LED but a solid red on the other channel. I'm going to turn it off, and then while it's powering off, we have single flashes on the both on LEDs with the red clip light still illuminated. Okay, I'm just going to let it turn off, let all the voltage dissipate, and then I'm going to turn this off. Greetings from Norway, how's it going? There we go. Okay, so now I can switch this off, and obviously still be careful because there could be high voltage inside here. I'm just going to give it the old sniff test, just to see if I can smell if anything was overheating in here. Don't think so. Okay, cool. Right, let's have a look at the manual then, because I don't recall seeing any mention of single red clip LED for a fault code. So let's bring up the manual, shall we? Let's see what we can find. Let's go to Google and see if we can find it. Okay. So if we scroll down far enough, we will find the table. that denotes all of the flash sequences somewhere. There we go. So what we had was the green LED permanently lit. So for one of the channels, that was fine. Now when we turned the switch off, we got pulses like this on both channels, which is power fail, which might make sense because we've just turned the amplifier off. Now I don't know, because this is the first one that I've ever powered up. This is the first one of these I've ever powered. So I don't know whether powering the amplifier off, the kind of power down sequence, is just to kind of go through this power fail mode, because obviously there is a power failure because you turned it off. So that could be normal, but that may not be normal. We have, see now this table is relating to the power LED. I want something that tells me about the clip LED. Problem, no sound. Indication, on LEDs not lit. No, it is lit. On LED lit, signal LED not lit. So I want to find the clip. On LED, not or sporadically lit. Signal LED not lit. Clip LED lit. Okay. So it could be that one, but the on LED was correctly lit. But this one says under impedance limiter is active. The load impedance is abnormally low or shorted. Well, it can't be that because we don't have a load connected firstly, and even if there was a short across the speaker terminals, the amplifier wouldn't know it yet because, well, unless it does some kind of health check across the speaker terminals, which I've never seen before, but it wouldn't know that because we haven't actually attempted to put a signal through this yet. So it wouldn't know what the impedance was or whether it was a short. So let's just scroll up here, indication of on, so let's just find the next clip LED. When switching the amplifier on, the on LEDs flash twice, accompanied by a flash of clip LEDs. This is normal start. Okay. Please refer to the on LED flashing sequences. That's not what we want. On all other on LED sequences that shut down or mute the vortex indicate a serious internal fault. So I'm not seeing it tell us anything about a constantly on clip LED. Perhaps we should try putting some signal through it and seeing whether there's any output from the channel that has the red LED, although I assume not. So I think what the best thing might be to do is just to strip this down and investigate the channel that has the red clip light. Valentin says, first time being here live with you. I'm a huge fan of your work. Oh, thank you very much, buddy. Appreciate that. Greetings from Romania. Greetings to Romania from myself. Was that buzz of the transformer charging the caps? Yes, it was. That was the rail caps charging, or the bulk caps charging. One side's in protective mode. It does certainly look like that, doesn't it? Mine does that too during power off. Oh, thank you very much, Sam. That's great information. That's just confirmed that is what they do during power off, so that's fine. One side in protective mode. Maybe we should scope the outputs and see what the outputs are doing. See if there's any DC. Although if there was DC, we should get a flash sequence, shouldn't we? Evening, Rob. How's it going, buddy? Okay, so let's just check to make sure that the voltage inside has dissipated to ground. So that as we start to take this thing apart, we're not going to get a shock from the bulb caps or anything like that. Okay, so we've got 21 volts there by the looks of it. So there is still a little bit of voltage in here. $20 volts. That's nothing to be too scared of. Okay, cool. Tron says, yeah, I'll look for DC on the outputs and unplug the preamp and see if the input was overloaded or the outputs are blown. That's not a bad idea. We could unplug, because the preamp circuit, well, the input board is here, but this doesn't really have any preamp components on it. The preamp is all here, I think, by the looks of it. Lots of op amps, lots of LEDs on the board here. We could look at the LEDs and see what they're saying. Yeah, we can't unplug or get rid of the preamp as its own, you know, in its own right. The microcontrollers down here. I have seen a couple of posts and videos about these amplifiers. I was doing a bit of research today of people saying that the microcontrollers can actually go bad on these, and that would be a massive shame. Because obviously a microcontroller can't replace that because it needs to be programmed with the firmware from factory. So hopefully we don't have one where we have that fault, because that would suck. But yeah, I think we should start stripping this down potentially, just so that we can get a better overview of these boards and check all of the output devices as well, I think. Or maybe we should just power it and see whether we get signal or any DC. What would you guys do first? This is kind of a bit different for me. So I'm just trying to, because obviously stripping this from the case is like quite a, you know, it's not the quickest thing to do. It's going to take a little while. So if we can do some diagnosis without stripping it, that would be cool. Ground lift. We're in stereo mode at the moment. Limiter. Let's turn the limiter off, shall we? Just for jokes. Guess the gain sensitivity. Now, in terms of connecting a speaker or testing this speaker outputs, we probably are just going to have to probe these wires. I do have a speak-on wire in the loft that I can go and grab. Looks like we've got one of the channel's outputs here, this orange wire, and another one is likely this red cable here. Yeah, we have red and orange as our outputs from the amplifier stages. So I can probe the orange one from here. I don't think I can get to the red one from here. Maybe I can just squeeze the oscilloscope probe in there. J Wolf, I take the insulation off and check the output on the bad channel. So basically this is just a heatsink. I don't know if you can see that on this other one that I've got here. This is just the top of the heatsink. So all of the output components are underneath this heatsink, and to remove this you have to take the whole board assembly out, flip it upside down, and then unscrew the heatsinks from the underside of the board, and then they come off. So that's the only way I'm going to be able to get to the output transistors, unfortunately. But I was just seeing whether I could actually probe both of the channels just to see whether there was any Class D switching or Class D remnants, just to confirm whether both channels were actually switching or not. So I was going to see if I could get my scope probe in there, but I don't know if I can. I could probably just poke that through the cable like that. Yeah, that'd be fine. Yeah, so we are actually making a connection there on the scope, as you can see by the little bit of noise there. So let's turn on channel 1 by itself. And we want DC coupling. Let's go for 10 volts divide for now. And in terms of a ground reference for the scope, I assume that this amplifier isn't full bridge, but it might be. So I don't think I want to go straight away connecting the ground of my scope to this black. Although, actually no, hang on a minute, this wouldn't be full bridge because it's bridgeable, so it is definitely half bridge. So yes, we can connect our oscilloscope ground to this terminal right here, which is ground. Let's just see if there is a... oh, it's actually the same ground as case ground. That's really handy. Which actually means that my scope is going to already have a ground reference for the speaker terminals, because this ground is all connected to the ring main ground and everything's grounded together. So I don't actually need my scope ground connected unless I want absolutely no noise on the scope screen, which I'm not too bothered about right now. Yeah, multimeter cam, always glitching. You love to see it. Glitch all day long, multimeter camera. That's how it lives its best life. I don't know why, but it does. It loves to glitch. You can kind of stop it glitching a little bit by moving it around a little bit sometimes, but I think honestly the shielding is just really bad in the wire for it. But it's super frustrating because only this style of camera really kind of fits here for the multimeter. Like I need a really compact, small camera. You know? So there's not really much else I can put here other than one of these type of cameras. Anyway. Yeah, so, okay, cool. Yeah, let's power it up again and let's see if either of these channels are showing us anything different on the scope from one another. So let's go down on there. Let's hit the plug switch. Let's power on. Okay, we're alive. Red LED. Let's probe this first one. Okay, on the scope we have a little bit of noise like that. And on the second one we have the same, about the same actually. Now that noise could just be noise due to you know, my scope not being very grounded, but at least we don't have any DC. So there's no DC on either channel here. Okay. Let's check the LEDs. There's no LEDs on the main board. There are some LEDs on the board just here. I don't know their function yet because this is literally the first time I've ever looked at one of these amplifiers. We do have an LED on the board down here, which is cool. Are there any missing LEDs? Probably not. Okay, let's go off. Wait for that to shut down. I'm just interested actually, can I probe the power supply, the SMP, from here? I think we can. I think I'm going to need my times 100 probe actually. So I'm just going to swap my probes over. So I've got my times 100 multiplier probe. So we're on 500 volts just now. Now of course, because we are on mains, we do have 50 Hertz there. I'm just going to power up again and I just want to see what the SMP looks like on mains here. Okay. Okay, there we go. So we have some PWM, which looks like that. And obviously it's riding on 50 Hertz, which is really annoying, but at least that shows us what should be on the source of that and that. Okay, this is kind of scary, so I'm going to stop probing around in there now. Fucking hate working on main stuff, guys. I hate working on main stuff because I've got stupid amounts of current available, and it's all very high voltage on the power supply side. I prefer a low voltage power supply that creates a high voltage. That's what I prefer. I think it adds character. So what's the issue? Well, the issue is that the clip LED remains on for one of the channels, and I assume it has no output. We haven't tested that yet because I haven't got a signal going in yet, but we assume it has no output. So this is what we're just slowly trying to figure out. I'm not rushing with these guys. I'm not rushing with these. Just kind of taking it slowly and just trying to learn bit by bit what we have going on this amplifier without kind of jumping in the deep end too quickly, because there's a lot of voltage, a lot of power here. I just want to make sure we don't miss anything. I'm just checking to see whether there's any high voltage remaining in the board. It doesn't look like it there. Okay, cool. So, I think what we should do is try to run some signal, perhaps, into this. Now, this takes signal via XLR. My bench, I should have prepared. My bench is not set up for this. I don't have XLRs ready for signal in. I have RCAs. So what I do have though is I do have an RCA to XLR adapter. So let me just grab that real quick. Nope, never mind. I can't grab my XLR to RCA adapter because it's downstairs. It forms part of the subwoofer setup downstairs, which is fine. But what we can do is probably just touch, if it's all common, we can probably just touch the tip of the RCA on the XLR pin. It would help if I re-enabled my hat cam. There we go. So obviously with the XLRs here, our inputs are going to be either of these, I assume. Channel A, channel B. So I don't know XLR pin out off the top of my head. So is it 1, 2 or 3 that is signal in? I know that they're balanced. I assume it's probably 1. So I could probably just touch my tip on the 1, and because everything is connected ground wise, that should give enough signal to just at least see whether we have an output on the speaker terminals. Okay, so I have about 18 ohms between the XLR ground and the chassis ground. So everything is grounded together, albeit just with a slightly higher resistance because it's going through everything. 1 ground, 3 cold. Okay, so in that case then the ground isn't actually common, but the cold is common. You want 2, which is the middle pin. So if I touch the RCA on 2, the middle pin, I should get some output, I would assume. So I guess let's test that, shall we? Let's turn my signal generator on. What's up, Strictly Amps? How's it going, buddy? I'm trying to start my own label and order some amplifiers from China to try out, but I think my preamp had too much input volts and fired one of the FETs. It's a Volt Max is volt max input. Not sure what that means. In a place I was at, I combined a 3.5mm cable and an XLR cable. Nice. When I looked up the preamp, it's running pushed. I'm not sure you're mixing up volts and amps here, buddy, but overvolting the input stage wouldn't inherently blow a FET, but if you were clipping the amplifier as a result of too much input signal, then yeah, that could blow a FET. How's it going, Will? Good to catch the stream. Yeah, good to catch you, buddy. No, it's balanced. Cold is reverse phase signal. Oh, okay. Well, cold in this case is connected to ground via about 20 ohms. So, I don't know if that's normal or not, but that's what we have. Alright, so let's go down to about, let's give like 70 hertz or something like that. And we're going to power it up again. I'm just going to touch this RCA on the middle pin of these XLRs over here. And then we should hopefully get some output on at least the working channel, and then we can see what the bad channel is doing or not doing. Okay, so mains is going on now, and switch is going on now. Rail voltage is built, amps come alive. So if we probe this orange one here, and then just touch, which I'll probably need to turn the potentiometers up a little bit, just a touch, not too much. I just want to see if there's a little bit of signal that appears. Oh, there we go. We have signal on orange channel here. Okay, cool. It's a little bit of signal, but there is a signal there. So if I just turn this up a little bit, this signal level. Okay, there we go. We have signal on the orange channel. So let's probe the red channel now, which is this one. Oh, we have signal there as well. Alright, well the amplifier seems fully functional. We have 5.3 volts RMS and 2.3 volts RMS, but that's because probably the potentiometers are not turned up to the same amount. No, they're not, they're very different. So, seems like we have signal on both channels, but the clip LED remains on at all times. I wonder whether that's actually a fault in whatever circuit lights up that LED. And the reason I say that is because the clip LED stays on even when the amplifier is fully powering down, when the SMP is like off and basically the rail voltages are just sinking down. So I reckon this is actually just a very simple, like, well, I say a simple, not necessarily simple, but there's nothing wrong with the amplifier itself, just with the circuit that does the user interface, you know, the LEDs. Would it be hard to change out the FET if I ordered it? Dude, you cannot change just one MOSFET. Please read Perry's guide. Go to bcae1.com, download, buy, purchase the amplifier repair guide from that website. It will tell you everything you need to know about amplifier repair. It's probably not just one MOSFET that's died, but even if it is just one MOSFET that's died, you need to replace all of the MOSFETs that are either in parallel with it, or ideally that are in the same section as it, either power supply or output side for that channel that it's in. And you might also need to do some drive circuit repair as well if that blowing FET has taken out the drive circuit, but I'm not going to be explaining that all this evening, so I say that basically every stream. So just buy Perry's guide and it explains everything in there. Hello Melky, how's it going? We don't have that many viewers this evening, guys. This is not a popular stream. But you guys that are here are the OGs, I guess. Right, okay, so I don't really think that I need to be pulling this whole thing out of the heatsink, because both channels are in fact creating perfect sine waves and are operating perfectly fine. So I think that the issue is likely to be somewhere over here to do with that red LED. That's really strange, isn't it? Now, which one was it? Was it the top one or the bottom one? Now, this kind of front module is a separate board. It's like a daughter board. So I wonder whether I could take this daughter board here and swap it from another one of these amplifiers. I've got 7 of these, guys. I've got 7 of these amplifiers. So I could swap it for one of the others and just see if the LED stays on the same or not. Strictly amps. What problem are you having? We've just tested the amplifier, and both channels are producing clean sine waves, no excessive current draw, there's no protection flash modes or anything like that, no excessive current, no blown fuses, everything seems fine, both channels producing dead clean, perfect audio. But the clip light is constantly on one of the channels. So we assumed that that was because the amplifier was in protect or something, some fault with the channel. But I actually believe that it's a fault with whatever circuit drives the clip LED. This transformer here is probably for generating auxiliary voltages for like plus minus 15 volts for all of the drive circuitry to work on, buddy. Is it a class H amp? Yes, it is a class H amp. It is. It is indeed. Okay. Where is the circuit for the clip LED? Godfrey, that's a great question. I would love to tell you that, but unfortunately I don't have a schematic, so we're going to have to figure that out for ourselves. So we have a ribbon cable here that connects this daughter board that has the LEDs on it to here. So this is where the signal for that LED being turned on is originating from. So we just kind of need to maybe just kind of go blind here, probe around and see if we can find any shorted little transistors or anything around here. Or shorted diodes or something like that. Something really simple that would cause the LED to just remain on at all times. I wonder if... Well, what model Vortex have you got? It's a Vortex 6, buddy. Sam, it's Vortex 6, this one. I've got Vortex 6s and Vortex 4s, but this one right here is a 6. Let's grab the multimeter again. And let's just see whether I can trace back which LED was it that was on? Was it the top one or was it the bottom one? Guys, can you remember was it this one on the top or was it this one on the bottom? I've got a feeling it was this one on the bottom, maybe? I'm just going to use my multimeter right here and just see if I can trace back where the clip LED signal originates from on the board, because we don't have a schematic. Right, that one there, that's clip LED, going in there, positive, so it's going to be that pin there. Now, where do you connect to on the main board, perhaps? Someone says top, someone says bottom, so I've got conflicting answers there. Can I find the LED? I don't know whether this this daughter board here has any circuitry on it of its own. or whether it's just like traces. I think it might have some circuitry on it of its own, because I don't have any continuity to any of the pins on the ribbon here. So I think a sensible thing to do might be actually just to remove this daughter board and investigate that a little bit. So that's what we're going to do next. And what I need for this is my little mini ratchet. What's up, Sam? Super happy to catch you on one of your live streams. Much love. Thank you very much, Basehead598. Appreciate you, buddy. Appreciate all the love. Hope you're doing well. To find my mini ratchet screwdriver really for this. Just pop the top on another 6 and plug in while the cable is standing on its side. That's a good idea. I do have another 6 downstairs that I could go and grab. But I just want to investigate this. Actually, I see what you're saying, because that would mean that I wouldn't have to disconnect this board, wouldn't it? I could just have another 6 here with the top off and just plug in the ribbon cable. That's a good idea, actually, David. Yeah, I might give that a go. That is a good idea. Okay, I will do a BRB then, while I go and grab another Vortex 6. I assume that the daughter boards are going to be different between the Vortex 4 and 6. I mean, they might be the same, but they might be different, so yes. Late to stream. It's not that late. It's only 8 o'clock. Oh, you're late to the stream. Yes. Damn, this is not a very popular stream. 54 people watching. Damn. Right, let me BRB then, and I'll go and grab another Vortex 6, see what we can find. Oh, main camera has died, as always. Come on. There we go. Okay gents, another Vortex 6. Like I said, I've got 7 of these amps, a couple of Vortex 4s and mostly Vortex 6s. So let's pop the top off this one and swap the cables over between these boards. Has anyone seen the video I just did on the Big Boss 8? And if you did, what do you think about that weird mode that it has under 11.5 volts? How weird is that? Very interesting behaviour. I think if anything it protects the amp. I don't think it protects the sub really. Are you getting into more PA or home amp repairs? Yeah, I'm getting a bit more into it. I'm not advertising them. But if someone says, oh Sam, can you look at this? I'll be like, yeah, go on then. Tron says, yeah, if it was me having to fix all those amps, I would find one with 0 faults and use it as a guide to compare. That's exactly what I was hoping to do with one of these first ones. So basically, all of these have faults, and the one that I picked out to repair first said something like 1 channel clip LED on all the time. So I was like, okay, well at least we know that the switch mode power supply is fine on one of them, and we know that one of the channels is fine. So I could use the good channel and the working switch mode power supply to repair the others. But as it would turn out, I think we have one fully functional amplifier that just has a bad LED that's staying on when it shouldn't do. So that's really cool. So we do have one amplifier that seems to work just fine. Yeah, I know the cam's dead. I'm just trying to get it up and running again. Might be time for a new workshop PC, I think. Might be time for a new workshop PC or something like that. Better setup, I think, at some point. Okay, so yeah, this is the other. Oh my god, what's going on? Do I just give up at this point? Do I just give up at this point? Man, this is kind of awkward, not gonna lie. So these amplifiers make 6,000 watts RMS into 4 ohms and 1 ohm, depending on whether you use parallel mono or bridge mono. So that is connected. Problem is I can't bloody see it. I guess I could just lean over here and have a quick look. Okay, well at least that's connected, so I guess I can power this up now and just see whether the LED stays on or not. Because if the LED doesn't stay on, then obviously we know that the issue is just on this daughter board. So, okay, let's get the mains back on. Okay, powering up now. Okay, now the red LED, the clip LED is actually still on. So it's not the daughter board that's the issue, it's a fault on the main board here. Okay, you can see there that little red LED there still on. It shouldn't be on, and it's the kind of one on the middle of the case, the bottom one from where I'm looking at it. Okay. So let's unplug that. I'm running out of space in here. Where am I going to put this? Okay, so we know that the fault here is on the main board somewhere, so I'm just going to do what I do best. I'm just going to start probing some basic semiconductor parts around this kind of area, just to see if I can find any anomalies, anything that looks a bit doesn't look like it's reading correctly. I'm also going to try and get my camera working again, because that would be lovely, wouldn't it? Have error 70, that's fine, we've had that before. There we go, you love to see it. Now, can I get my multimeter cam working again? I don't think I can. I think the multimeter cam is dead for tonight, guys. F's in the chat for multimeter cam, so we're just going to have to go by what I say out loud, I guess. So, I'm just going to probe around where this header is here, see what we can find. See if any of these diodes look like they're reading incorrectly, or these little transistors. So we have 500 on that one, 560, 560, 560. Caps, 380, 380, 380, 380, 380, 380, 380, 380, okay. What's a little bit annoying is I would have thought I would have a direct connection between the LED and some of these pins. If there's no active circuitry on this daughter board, then there should be a direct connection between one of these pins and the red LED thing here, or at least something with a high resistance. So I'm just, oh, hang on a minute, here we go, what's that? We have 1K, could that be it? Could that be it? Nothing, 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 nothing. Aha! We have 1.2 kilo ohms between the red LED input and this third pin from the bottom. Okay, that's promising. Well, there it is then. So this pin right here is the red LED. So that gives us something to go by. So if we flip that upside down, that's the top third pin along on the board here. So that is our red LED, our clip LED that shouldn't be on. So let's see whether we can find out what that's connected to. Schematic would be amazing right now, but I don't have a schematic for this, unfortunately. There we go. D101. We have continuity to D101. Okay. D101. Let's give that a quick read. We have 564. And nothing. Okay, so that's reading correctly. Does anything else have continuity though to D101? Because, you know, there might be a few things that have continuity there. Unlikely, but possible. There goes the main cam again. It gave me a little fright actually. Okay, D101. So if we go from the other side of D101, you can see we have a trace that goes into a via just there. So where do you go? Hopefully not to ground. Nope, it's good. Probing the MCU, which you can't see, but let's zoom out a bit so you can see what I'm doing. So where do you go, you little trace? So I usually say, nah, you don't need schematics, but for things like this, really weird faults that aren't sort of amplifier circuit related, a schematic would be a legendary right now. Yeah, I'm not finding any continuity. I thought I might have continuity to the MCU itself. it goes up here.
I think this is all preamp circuitry though, so I'm pretty sure the clip LED is going to be controlled by like MCU because it has a few different functions. It's not going to be, I don't think it's going to be a passive circuit like a discrete circuit. I'm pretty sure it's going to be something MCU related. I just got to find out where this connects to. But not having much luck, so we might have to strip one of these amplifiers from its heatsink so that we can follow the via on the underside. That via right there, that goes underneath the board and it's going to pop up somewhere else. So we could try probing vias that are nearby, but yeah, usually obviously there's going to be a trace that goes on the underside of the board that goes off somewhere else. We don't know where it goes because we can't see the underside of the board. So the only way to see the underside of the board is to strip one of these boards out. But I'm just going to go ahead and just check a few semiconductor components that I can see on the board here, just in case there's like a very basic shorted SOT22 or a little glass diode or something around here. I doubt it, but it's like something to check. It could even be a bad via, like this could supposed to have a connection to the MCU here. What might be fun is to grab the other Vortex X from down here and actually just see what that one has in terms of continuity from that same pin. I hope your headache gets better, Latvian. Apologies for that. So pin 3 on this one from the top. This board layout looks a little different, hey? This looks like a slightly different revision PCB. They're both Vortex 6, correct? Yeah, Vortex 6. This one, Vortex 6. Both Vortex 6. But yeah, the board layout's a little bit different. Now, that might come in handy because the trace might be visible on this one. So pin 3, this diode, D101, still D101, goes to this via. Unfortunately that via still disappears off under the board, so that doesn't really help us. But this board actually is a little different in terms of its makeup, and also it looks like we have some kind of weird modification or something that's going on over here. What is this? Capacitor and transistor have been added after the fact here. Weird. Maybe that's why there was a board revision to add whatever this is. I don't know if that's factory or not, no idea.
Yeah, now I think that we're going to have to take one of these out of its case at some point, so we can just follow that trace. I might have to start off with, oh, what the heck, again? I might have to start off with one of these amps that has a more drastic fault, so that we can definitely, you know, take it out of the case. Because I don't want to have to take one of these out of the case unnecessarily, if you know what I mean. Like this one that has the clip LED that's on when it shouldn't be. We don't need to take that one out of the case really, because probably whatever issue there is on that one is going to be surface mount related. So yeah, I think we maybe should go and grab one that definitely needs the board taking out. For example, one that's got that's blowing fuses or something like that, and then we can investigate where that trace goes and learn a bit more about the one that has the clip LED that's still on. This one here definitely has a whole bunch of modifications made to it. We've got this transistor and capacitor sitting here. We've got this capacitor which is like bridged over under the transformer here. Any other weird mods or things done? Yeah, we've got more capacitors bridged over the top of these diodes here. So I think this board was like an earlier one that has had some revisions done to it that then they did a full board revision of for a next batch. Interesting. This is kind of a lot to do on stream, I'm not going to lie, in terms of like how much crap I've got in the workshop right now and I can barely move. Maybe I'll do something else this stream. This isn't doing that well anyway, this stream. I've got like 50 viewers. So maybe I'll do something else and won't stream these repairs because I don't think they're too interesting and they're kind of difficult to stream. Yeah, I think what I'll do is regroup with my ideas and do some more live streams later on in the week and over the weekend that are more car audio related. I think those get the best viewership and they're much easier for me to stream because I know them better and it's all confined to the workbench and it's not these massive things that are difficult to kind of take apart. And I will just work on these in my own time, I think. I was going to make a video of working on these, but honestly I don't have the time to sit and edit all of the clips that would need to go with these. This is going to be like a long video. So yeah, I think we'll do something else for the streams, but I hope you found this a little bit interesting and entertaining. It was good to see some of your guys' faces, some of your guys' names again, but yeah, I'm probably just going to lock off the stream here and try and sort out the stream reliability with the cameras a bit, so that the cameras don't keep dropping out and just so it's a bit easier for me, because it's not fun when you're trying to do a stream and work and the camera keeps dropping out. Can't get a bigger workshop. This is the biggest room I can take up in the house, unfortunately. Get rid of some of the crap that's in here, maybe. All the stuff that's in here is stuff to be repaired. I'm so busy at the moment, I just don't really have the room. But yeah, take it easy guys, thanks for dropping by.